The solvent is like your entourage, which can prevent your fans from getting to you. A substitution reaction occurs by an SN1 mechanism or SN2 mechanism. Let's see how the solvent affects the nucleophile or substrate or intermediate in each mechanism. Organic chemistry textbooks like to show the different factors which affects each mechanism type. Let's focus on the solvent and see how polar protic or polar aprotic solvents affect the substitution reaction mechanism. We looked at polarity earlier. A protic solvent is capable of hydrogen bonding, but an aprotic solvent will not involve any hydrogen bonding. Note that the first three solvents are polar protic solvents, which involve hydrogen bonds. The last four solvents are aprotic solvents. A polar protic solvent like water can stabilize a nucleophile such as chloride by hydrogen bonding. So water behaves like a bodyguard and doesn't allow that nucleophilic chloride to react. So the leaving group in the alkyl halide substrate can leave and the polar protic solvent stabilizes that carbocation intermediate. A polar aprotic solvent does not solvate or surround a nucleophilic reactant. The nucleophile can then react with the substrate, the alkyl halide, to form the substitution product. Let's compare reaction 1 to reaction 2. Stop the video, read this information, and then you can answer these two questions. So the answers are, you want to do these two synthesis reactions to convert one functional group to another. You figure you can use a substitution reaction. So stop the video and determine the reaction conditions, that is, the reagents and solvents for each reaction. For the first reaction, note that the alcohol is a tertiary alcohol. That means the reaction will occur via an SN1 mechanism. So you can use for the reagent solvent. For the second reaction, you have a secondary alkyl bromide, and it looks like there's an inversion configuration going on. So you'll want to do an SN2 mechanism and use a polar aprotic solvent. So the reagent and solvents you use are. So good job figuring out the conditions for each reaction. So let's review. Stop the video and answer these questions. So here are the answers. A polar protic solvent stabilizes a reactant or intermediate. So ethanol is the polar protic solvent of the list of four. For 1B, you're starting with a primary alcohol. A primary substrate undergoes an SN2 mechanism, so you'll need an aprotic solvent. Between methylene chloride, ether, and THF, you use a solvent in which the 1-butanol is most soluble. For 1C, 2-butyl bromide is a tertiary alkyl bromide. So that reaction occurs via an SN1 mechanism, so choose a protic solvent. And for question 2, the energy diagram shows a reactant, intermediate, and product, but must represent an SN1 mechanism. In 2013, an article in Chemical Engineering News appeared on why SN2 reactions don't work in water. Water is a polar protic solvent, and water will stabilize the intermediate. Water does such a good job of stabilizing the intermediate that the activation energy to get to the transition state is so high that the reaction is too slow to get to the product.